In this question, we are told that a wire that is 60 centimeters long is cut into two lengths, x and y. The first length x is formed into a square, and the second length y is formed into a circle. If the total area of the two figures is a minimum, what are the lengths of x and y to the nearest tenth of a centimeter? The first thing that we need to do in this problem is come up with a function for the perimeter. The perimeter of the two objects is p is equal to x plus y. If you take a look at the square, you'll notice that the side length is x over 4. But if we have 4 of those, that adds up to 4x over 4, or simply just x. And of course the circle has a perimeter of y. In addition, we also know what the perimeter is. We know that the perimeter of our objects is 60, so we can substitute 60 in for p. Now, in order to isolate for one of our variables, we can move either the x or the y to the other side of the equation. In this case, let's isolate for y. To do so, we will subtract an x from both sides of the equation. Now that we have come up with a function for the perimeter, we need to come up with a function for the total area. Let's start with the area of the circle. We know that the circumference of the circle is equal to 2 pi r. And if we do a little work here and rearrange for r and divide 2 pi by both sides, we're left with that the radius is equal to y divided by 2 pi. This is useful because we know that the formula for the area of any circle is area is equal to pi r squared. Because we've rearranged our initial function for r, we can now substitute that information into our new function such that we only have our variable y left inside. So if we take a look now, we've substituted this in for our r such that we have area is equal to pi, and then our radius now we have y divided by 2 pi, which is all being squared. Now if we square this, we have y squared, and 2 squared is 4, and pi squared is just pi squared. Notice that the pi and the pi squared will simplify. And then now what we can do is we can take this function that we had at the beginning here, our perimeter function, and substitute this into the area. Because we knew that y was equal to 60 minus x, that 60 minus x can be substituted in for this y right here. And now we only have x's in our function. Now from here we can expand. 60 minus x all squared is the same thing as going 60 minus x times 60 minus x. 60 times 60 is 3600. 60 times negative x is negative 60x, another negative 60x, and then negative x times negative x is x squared. And then finally, gathering our like terms and putting descending order of powers, we have found that the area function for our circle is equal to x squared minus 120x plus 3600, all divided by 4 pi. Notice that we only have one variable left in this function. It is a function of x. Now that we have determined an area function for our circle, we can find the area function for the square. The square is a lot easier. If we take a look, the one side length is x over 4, and so if we simply just square x over 4, we have the area of the circle. So notice that we have x over 4 all squared. The circle was a little bit more complicated because it was in terms of y, and so we need to do some work to get it in terms of x. Now, you'll notice that our entire function has only x's. From here, we can take the x over 4, and since it's being squared, we have x squared over 16. Now from here, we need to get ourselves a common denominator. In this case, our common denominator ends up being 16 pi. So we'll multiply both the numerator and the denominator right here by pi, and we'll multiply the numerator and denominator here by 4. Then from here what we can do is we can start gathering our like terms. If we gather pi x squared and 4 pi x squared and change them into a decimal, we have 4 plus pi, and then divide all this by 16 pi gives us the decimal 0.142. Negative 480 divided by 16 pi gives us negative 9.549, and 14,400 divided by 16 pi gives us 286.479. If you take a look at the question, you'll notice that it says to round to one decimal place. We've included a couple extra decimal places to make sure that our answer is precise. You'll now notice that this question is in general form. It may look a little bit more complicated than normal because of the decimals, but we're still going to follow the same form we normally do. So, we will factor the 0.142 from our first two terms. When we do so, we're left with the following. Next, we'll take this term and divide it in 2, and then square it like we normally do, which generates 1,130.17, and we subtract the same amount. This negative term now needs to be multiplied by the leading coefficient and brought outside. When we do so, we get negative 160.484. We'll now gather our like terms and complete the square. When we do so, we have found our x dimension and we found our minimum area. So our x dimension is going to be approximately 33.6 when we round to one decimal place. And to find y, we just need to take our initial function, y is equal to 60 minus x, or in this case, y is equal to 60 minus 33.6, which gives us y is equal to 26.4. We have our two dimensions. Finally, let's check our solutions. And we are correct.